Okay, and finishing up now on section 9.4 are vectors. Any vector that we have, we can break down into a combination of two vectors. And vector I is 1 unit long in the positive x direction. So that's called a unit vector in this direction. We also can have a unit vector in the positive y direction. The name of that vector is j. So anything that we want to plot is a combination of I and j. And as an example, if I have vector v, which is defined as 8 and negative 3, I can write that as 8 times vector I minus 3 times vector j. So these all mean the same thing, but this allows us, the nice thing about I and j is they're perpendicular to each other. So it'll allow us to do some trigonometry. So let's go through and take a look at this now. So if I have vector v defined as 2i plus 3j, I could write it like this. And vector w is 3i minus 4j. Again, we can write it like that. If I want to add vector v and w, I can add the coefficients of the i and the coefficients of the j. So I have 2 plus 3 times vector I plus 3 times, plus a negative 4 times j. So my resulting vector of vector v plus vector w is 5i minus 1j. And you don't have to write the 1, I'm just emphasizing it there. Likewise, if we subtract vectors, we can do them the same way. So if I want to say vector v minus vector w, 2 minus 3 times vector I plus 3 minus a negative 4 times vector j. So that gives me a negative 1i plus 7j. This is the resultant vector that we get when we subtract vector w from vector v. We can also do some scalar multiplication here and combine them. I know there's a lot of stuff here, but let's just start. If I have vector v is 2i plus 3j, 3 of those is simply we take 3 and multiply it by both the I and the j. So 3 times 2i gives me 6i. 3 times 3j gives me 9j. This is the vector that represents 3 times vector v. 2 minus 3w. So here we're going to take 2, multiply it by vector v, and then subtract 3 times vector w. So that's 3 times vector w is in here. Simplifying, we have 2 times 2i is 4i, 2 times 3j is 6j, minus 3 times 3i gave me 9i, and 3 times negative 4j gave me negative 12j. And I'm subtracting. So I have 4i minus 9i gives me 5i, 6j minus a negative 12j, so I'm going to have to add this, gives me 18 times vector j. Next up is the magnitude of vector v. Remember, the double bars mean magnitude. And the magnitude we find by squaring the x component plus the y component. So 2 squared plus 3 squared square rooted, and that just gives us square root of 13. So that is the length of that vector. Remember, magnitude is a length. It has no direction associated with us. It's just a scalar. Okay, the next thing, this one is a little bit more complicated, and it's a unit vector. So just to understand that, is if I had this vector, let's just use v, and it went 2 units this way and 3 units this way. So there is my vector v. The length of that, we said, was the square root of 13. Well, if I want to have a vector going in the exact same direction, but only with a length of 1, it is what we call a unit vector. So I want to find this vector, and again, we just are going to call this u, but it goes the exact same direction as vector v, but the length of it is going to be 1. Well, the way we do that by definition is we take our vector v and divide it by its own magnitude. So here we've got a vector 4i minus 3j. The magnitude of that, Again, 4 squared plus negative 3 squared, square rooted. And that gives us 16 plus 9 square rooted, which is 25. Square root of that is 5. And the magnitude will be a positive number, so I don't have to worry about taking the negative. So to get my unit vector in the same direction as vector v, I take vector v and divide it by 5. So the components of vector v are 4i minus 3j. So both of those get divided by 5. And so I write it as 4/5 vector I minus 3/5 vector j. And if I were to find the magnitude of this vector u, it will be 1 because it is a unit vector in that direction. Okay, and again, you can always check yourself by going back. So 4/5 squared plus a negative 3/5 squared, square rooted, will give me 1. Okay, we'll take a look on the back. We're not going to go through everything back here, but let's take a quick look back here. So if I have a vector, length 6 and an angle of 40 degrees, can I write the horizontal and vertical components of this vector? So I know this is what it looks like. I'm going to build a triangle. We should be very familiar with these. This is x and this is y here. Well, we know the cosine of 40 degrees is the adjacent side divided by the hypotenuse. So cosine of 40 degrees is x divided by 6. Multiply both sides by 6, and I get x is 6 times the cosine of 40 degrees. Put this in the calculator, and I get x is 4.596. And that's just rounded to 3 decimals. Likewise, to get the vertical component, I've got to use sine. So I'm trying to find this amount. So sine of 40 degrees is y divided by 6. Multiply both sides by 6, and I get that y is 6 times the sine of 40. Put it in the calculator, round to 3 decimal places, and we have y is 3.857. So this is my horizontal component. This is the vertical amount, but I've got to multiply them by the unit vectors in the horizontal direction and the vertical direction. We do the same thing here. This one is more of a velocity problem. I have a I assumed baseball, but a ball thrown, initial speed of 25 miles per hour. That's my scalar. That's the length of the vector in a direction that makes an angle of 30 degrees with the positive x-axis. So again, to find the x value and the y value, we're just going to use our trig. So x is 25 times the cosine of 30. Y is 25 times the cosine of 30. Put them in the calculator. So I've got my horizontal component, my vertical component, and I have to multiply them by the unit vector to make them into a vector versus just a number out here. So vector v goes 21.651 units in the positive x direction, and then up 12.5 units in the j direction. So if I break this vector into the 2 components, that's how we do it. And we're not going to worry about the last bit here, so that should take care of the rest of our notes. Feel free to ask us if you have any questions.